Perfect.
All right. Well, we're in chapter 30 of Tech Math 4, and we're doing section 4.
2.
And
43.
section 4 was solving problems, so we're going to start with number 9. An electric circuit has an inductor, a resistor, and a capacitor. All right, so there's that guy, there's that guy, there's that guy. So we got inductor, resistor, capacitor. Now, we know everything about this circuit, right? I mean, what could be any news to us? It's just normal. No, I got a battery. 12 volts.
Oh, okay.
What is it? 0.1 Henry. And 200, is that what that is? 200? 200 microfarads. And then there's a battery. That's 12 volts. Okay? Find the equation for the current. Well, V is equal to IR. What more do we want? All right, so the voltage across the resistor is I50, also known as IR. The voltage across the inductor is DI dt L, or 1/10. The voltage across the capacitor is Q over C, or 200 microfarads. Kirchhoff's law says that 12 has to equal the voltage across the resistor, IR, I50, plus di dt times 1/10, plus Q over 200 microfarads. So we have one variable I and a second variable Q, and we know from past experience that I is dq dt. So current is change in charge, change in time. So I'm going to rewrite the equation and say 1/10 Q. 1/10 Q double prime, because di dt, I take the derivative, it's the second derivative. And that doesn't look like a Q though, it looks sort of like something different than a Q. Q plus 50 Q prime plus Q over 200 microfarads has to be 12. Okay, because there's, so whatever the drops across each of those components, when I get done, it has to equal 12. Well, I'm going to multiply by 10 and get Q double prime plus 500 Q prime plus 10 over 200 microfarads Q is equal to 120. Now I'm going to take out my calculator and find out what the heck is, why am I in binary? That would be pretty bad if I stayed in binary. Okay, so what is 50, what is 10? 10 divided by 200 micros is 100,000? No. 10 divided by 2 double E minus 4, that's better, is 50,000. So I'm going to change this to Q double prime plus 500 Q prime plus 50,000 Q is equal to 120. Alright, and I'm trying to find an equation for I. So if I solve for Q and then take the derivative of Q, I will have my answer for I. Okay, I have an initial condition. Fine. No, I don't have any initial condition. So turn the page, make sure I don't have no initial condition. But I do have a characteristic equation. r squared plus 500 r plus 50,000 is 0, and I'm not sure I can factor that, so I'm going to say r is equal to minus 250 plus or minus the square root of 250 squared minus 50,000 divided by 1. Okay, so 250 squared minus 50,000 equals 1250 okay, so 12,500. So the square root of 12,500 equals 11.9. So r is going to be minus 250 plus or minus 111.8. Oh, that isn't right. What's not right about that? What did I do wrong? Right here. No. I'm multiplying by 10, multiplying by 10, multiplying by 10, multiplying by 10. This should be a sinusoidal function, and I'm not getting a sinusoidal function, and that's why I am. Because it should go back and forth, and it's not going back and forth. Well, maybe that's right. I don't know. So r is going to be minus 362, or or 138, minus 138. So Q is going to equal C1 e to the minus 362t plus C2 e to the minus 138t. And then I, which is equal to dq dt, is going to be minus 362 C1 e to the minus 362t minus 138 C2 e to the minus 138t. Now, I really don't think that answer's right, and but it's odd, so it should be in the back of the book. If the back of the book likes that answer, then we'll go on. If not, I'll get out my red marker and find out where the mistake is. We're 30. I'm still in 28. Now I'm in 30. 34. 34, number 9. Well, son of a sea biscuit here. The author says that's right. Because C1 and C2 are constants, and we don't know whether they are until we have initial conditions, the author's answer is I of t is equal to C1 e to the minus 362t plus C2 e to the minus 138t, because until we apply initial conditions, there's no difference between minus 362 times C1 and C1. Okay, so am I done? Author, I don't think you have the right answer. Number 9. Okay, because I still need to find a particular solution. So Q sub P is equal to A, and P prime Q double prime P 0, 0, and if I take 5,000, I take 50,000 of that guy. So 50,000 A has to be 12, so that means A is going to be 12 over 50,000. But 12 over 50,000 is just a number, and so it's going to be plus 12 over 50,000. But when I take the derivative of Q, that becomes 0, and I end up having the right answer, so the author was correct. Okay, problem number 10. So we got lucky, got number 9 right, and this time we got to get it right without the author. All right, so I have a similar thing. I'm doing the electric circuit has 0.2 resistance of that, capacitance of that, voltage is that, fine current. So I'm doing the same thing over again. All right, well, if I have to do the same thing over again, that makes it easy, right? So I've got IR, or 400 I for the voltage across this guy, and I've got 0.2 di dt across that guy, and I've got Q divided by 500 microfarads for that guy. And this guy's 12. So I've got 12 is equal to 2/10 Q double prime plus 400 Q plus, okay, so I've got 500 double E minus 6 1 over. Where's my 1 over key? There it is. $2,000 Q, and this guy's Q prime. All right, I'm going to multiply by 5. So I've got Q double prime plus 2,000 Q prime plus 10,000 Q is equal to 60. Okay, I've got a characteristic equation, and the characteristic equation's R squared plus 2,000 R plus 10,000 is equal to 0. Using the half quadratic formula, I have R is equal to minus 1,000 plus or minus the square root of 1,000 squared minus 10,000. But 1,000 squared minus 10,000 is still, alright, well, that's alright, divided by 1. R is going to be minus 10,000 plus or minus. I've got 1,000 squared minus 10,000 equals, and I want the square root of that, 995 plus or minus 995. So R is going to equal minus 1995 and minus 5. Those are my two choices. So I of t is going to be C1 e to the minus 1995t plus C2 e to the minus 5t. And when I take the first derivative and the second derivative of that, this is Q, by the way, I'm going to end up with the same thing. Well, we'll do it. We won't talk about it, we'll just do it. Okay, so Q sub P, the particular solution, has to be A, Q prime P is 0, Q double prime P is 0, and I need to have 60 equal 10,000. So 10,000. 10,000 A. So A is going to equal 6 over 1,000. Okay, so Q of T is C1 e to the minus 1995 T plus C2 e to the minus 5T plus 6 over 1,000. And I of T, which is what we're looking for, is equal to the derivative of the charge. And again, I'm gonna just bring in the constant of integration is just going to suck in that number C minus 1995T plus C2 e to the minus 5T, and then that guy goes away because he's just a constant. All right. 2 more, and then we get to do Laplace transforms, which are even more fun. Number 11, which I have to get right because it is in the back of the book. Okay. Okay, so I've got a resistor, an inductor, a capacitor. Now, why do I have a resistor, inductor, and capacitor? Well, because I'm in chapter 30, and we're dealing with second-order differential equations. That's why I did it. So I got voltage across this guy, 200I. Voltage across this guy, 2/5 dIdt. And voltage across the capacitor, Q over the charge, which is 50 microfarads. And I have initial conditions that say I at 0 is 0. And do I have any others? And Q at 0 is also 0. Q at 0 is 0. So now I'll be able to solve for constants of integration. And again, I have 12 volts. So clearly, the problem doesn't say so, but there's some switch that I'm going to throw at time 0. And so my initial condition is I'm not charged, there's no current going, and then I throw the switch. And if I do the switch differently, so I got a switch here hooked up to there, and then I'm going to throw the switch up here at time 0. So right now I'm grounded out, basically, and I'm going to put the battery on later. Okay, so that being the case, 12 has to equal 200I plus 2/5 dIdt plus 1 divided by 50 double E minus 6, 20,000. 20,000 Q. And then we substitute in and say I is dIdt, I is dQ dt. So we'd say 2/5 Q double prime plus 200 Q prime plus 2,000, 20,000 Q is equal to 12. We wouldn't necessarily have to, but I'm going to multiply by 5 over 2 anyway to put the equation as y Q double prime plus 500 Q prime plus 50,000 Q is equal to 30. At that point, we have a characteristic equation, r squared 500r 50,000 is equal to 0. We could try to factor that, I suppose. R is equal to 250 plus or minus the square root of 250 squared minus 50,000 divided by 1. So 250 squared minus 50,000 the square root of. So that's, we'll call it 112. 112. So r is going to equal, that's a minus sign there, minus 362 or minus 138. And we've seen both of those numbers again before because we saw both of that numbers before. So q of t is equal to c1 e to the minus 362t plus c2 e to the minus 138t. And q at 0 is 0, which implies that c1 plus c2 has to be 0. Okay, but we can't apply the initial condition yet, so we're going to have to back off. Alright, so what do we do next? Oh, we have to figure out q sub p, which is A, and q prime of p, the particular solution is 0, and q double prime at p is also 0. And when I get done, I need 60 of them. And what am I multiplying by? I'm multiplying by, I need 30 of them. 50,000. 50,000 A, and that's really a 30. So A is going to be 3 over 5,000. And then Q of T, final answer, not final answer yet because we have to apply the initial conditions, minus 362T plus C2 e to the minus 138 T plus 3 over 5,000. Alright, now applying the initial conditions, Q at 0 is 0, which is C, which implies C1 plus C2 has to equal minus 3 over 5,000. Q prime of T, minus 362 C1 e to the minus 362 T minus 138 C2 e to the minus 138 T plus 0. Q prime at 0, which is also I at 0 in case anybody's wondering, is equal to 0 is equal to minus 362 C1 minus 38 C2. Okay, well, at this point, what we will do is we'll open a spreadsheet. Why not? I have a spreadsheet that solves simultaneous equations, right? So why don't we just open the damn thing and use it, right? Okay, so is it something I used recently? There we go. It's something I even used recently. Problem has occurred. A problem has occurred to you. Alright, well I guess we won't do that. We'll file open if it's going to be that way. And look at the U drive. And oh, it's not accessible. I don't believe it. I know you're accessible. Oh, there you are. Tell me you're not accessible. Looking for math. You see math yet? There it is, math. And there we go. Oh, yes, there we are. Okay, now, so we don't have 4 equations, we have 3 equations. Okay, so I have 3 equations, 3 unknowns, and I don't need that guy, so I'll get rid of him. And back to our problem. Okay, so the first equation was what? 1, 1. I only have 2 equations here. 1, 1 minus 3 over 5,000. Okay, so 1, 1 minus 3 divided by 5,000. Okay, that's good. And my second equation is minus 362 minus 1380. Minus 362 minus 1380. Alright, so it looks like I have 37 and minus 97 with a bunch of zeros in front of it. Alright. So, what were we supposed to do anyway? Anybody remember? Find the equation for I. Okay, so I of t is minus 362 times C1. 0.00. There we go. 0.0003. Can I have more? Alright, we'll go with 3696. 0.0003696 e to the minus 362t minus 138 minus 0.000 9696 9696 e to the minus 138t. Okay, now I'm ready to write down my final answer. Final answer. I of t equals 362 times 0.0003696 and minus 0.134 e to the minus 362t plus 138 times 0.0009696 0.138 e to the minus 138t. We're going to go back to that other guy to get another significant digit. 362. Oh, I already have it there. I'm going to change it to 3. Shit.
Same number?
Is it supposed to be 0? I of t. Yeah, they're supposed to be the same number, and they are. They're both 338. One's 3379, one's 338. 338. So they're both the same number. 1338 e to the minus. Okay, that looks good. Now, we're checking our work. I at 0 is supposed to be 0. Check, it is. Q of t Q of T out of that. The derivative of the charge is Q. The derivative of the current is in Q. Huh. Well, I guess I'm done. I'll look in the back of the book. Am I right? No? Yes? Someone's laughing. Oh shit, look at that. They rounded everything to 2 significant digits, yeah. Alright, well, I'm good. So they're calling this 360 and that 140.
Good or God?
Huh?
Good or God?
Yeah, so I'm good. Okay, one more problem, and we're done with this section, and then we're on to the next section. Now, we still haven't had any sines or cosines, right? So we deserve to have a sine or cosine sometime, don't we? Yeah, we do.
Oh no, you wrote God up there. That'd be a sign.
Yeah. So I demand a sine or a cosine in my answer. I mean, all these things are doing is just putting the battery on, and then they're dying down to nothing. Okay, I of 0, Q of 0 equals 0. This is 12 volts again. I mean, author, at least you could come with a different voltage every now and then. Being really boring. 1,000 ohms, 1/2 Henry, and at least we got 5.6 microfarads this time, so that's better. Microfarads. All right, so 12 is equal to 1,000 d the second derivative. Now 1,000 q prime plus 1/2 q double prime plus 5 1. Where's my 1? 1 divided by 5.6 double E minus 6. Well, that's just 178571 Q. All right, so there's my formula. I have a characteristic equation. 1/2 R. Well, before we do that, we're going to multiply everything by 1/2 so we get rid of something. All right, so I'm going to have Q double prime plus 2,000 Q prime plus, takes this number and times 2, 357,143. Q is equal to 0, is equal to 12. And then I have a characteristic equation, R squared plus 2,000 R plus 357,143 is equal to 0. Well, it's about time. Now I get an imaginary number. R is equal to 1,000 minus 1,000 plus or minus square root of 1,000, no it's not, squared minus 357,143. Shit, I still don't have an imaginary number. Oh, what a bummer. Plus or minus 1,000 squared minus 357,143 equals no it's not, 1,000 squared minus 357,143 equals
357,143. You're missing a 1.
Missing something. Alright, 1,000 squared, for this is the third time, 357,143 equals square root of my answer, 801. 801. So R is going to be minus 1,801, or it's going to be minus 199. Okay, now following the last thing, we're going to round these off to minus 1,800 and minus 200 and then we'll just carry those as our answer. So Q of t C1 e to the minus 1800 t plus C2 e to the minus 2000 t. Q, the particular solution, has an a, and the first derivative is 0 of that, and the second derivative is 0. And I've got, when I get done, what do I want? As I was saying, this should be 24 because I'm multiplying everything by 2. Okay, so I want 24, and I've got that ridiculous number to deal with, 357,143. So A is going to be 24 divided by 357,143. Isn't that lovely? Alright, so Q of t is equal to C1 e to the minus 1800 t plus C2 e to the minus 200 t plus 24 divided by 357,143. Applying an initial condition, while Q prime is at 0 is 0, that's going to imply that C1 plus C2 is equal to minus 24 divided by 357,143. Q prime at t minus 1800 Q1 C1 e to the minus 1800 t minus 2000 e to the minus, that's 200 t is equal to 0. This is I of t. Find the initial condition, current at 0 is 0, means that I have minus 1800 C1 minus 2000 C2. Alright, so I got two conditions, two unknowns. So I'm going to stick in there my 24 divided by the number that I have. Okay, so 24 divided by, is it 357?
Yes.
143. Okay, and then this guy was minus 2,000, maybe? I forget already.
It's 200.
1,800. Minus 1,800 minus 200. Did I gave you guys this formula, right? Is equal to 0. And that pisses you off, doesn't it? I wonder what that means. Oh, it could mean, no, doesn't mean the value doesn't fit in the hole. Now, why didn't it take 24 divided by 3475143? Why didn't it put a number there? What did I do wrong? Do I need an equal sign?
The one above it. Is that?
Oh, yeah.
There we go. So I didn't want to do that math right away. Okay, so now I got an answer. Okay, so now I have to remember what it is. And so, what am I doing? I'm solving, give the formula for I. Okay, so I of t is going to be minus 1800 times C1 minus 8.410 to the minus 8.410 to the minus 6 e to the minus 1 1800 t minus 200 times, we'll call it 7.6 10 to the minus 5 e to the minus 200 t. Okay, so 1800 times 8.4 double e minus 6 equals, okay, so I've got 0.015 e to the minus 1800 t minus 200 times 7.6 double e minus 5 0.015 e to the minus 200 t is my final answer, and I at t is 0, so that probably is going to check. Alright, so we're done with that, and now we're going to the next one. Okay. Now, in section 35, this is the way all electrical engineers always solve differential equations, because it's an easy way to do it, and as long as you have your Laplace transform tables, it always works. What it does is it takes a problem that's a differential equation and sends it someplace where I can just use 9th grade algebra on it. And then I send it back to the real world and tell you what the answer is. So what I do is I change it to an S domain, and then I change it back to the time domain. But I solve the equation in the S domain, and it turns out to be a simpler thing to do. Okay, so the first thing we do is we say, well, if I have some function f of t, then my Laplace transform, capital F of s, becomes integral 0 to infinity f of t e to the minus st. And then I solve this guy over and over again for a bunch of functions, and then I use it in solving differential equations. So give me a function. Andy, give me a function. F of t is equal to 1. Good choice, Andy. Good choice, 1. So f of t is equal to 1. So f of s. Now we can't take it interval 0 to infinity. So we have to take the limit b goes to infinity, 0 to b, 1, e to the minus st dt. And then we have limit b goes to infinity, e to the minus st divided by minus s, evaluated at 0 and b. Did it again. And then I got limit b goes to infinity. I put the b in, e to the minus sb divided by minus s minus e to the minus s times 0 over minus s. Now, as b goes to infinity, this guy goes to 0. As b goes to infinity, it doesn't matter because there's no b there. This becomes 1 over s. So the Laplace transform, if f of t were 1, then the Laplace transform would be 1 over s. And Laplace transforms are linear, so if I had f of t was equal to 2, then the Laplace transform would be 2 over s, because I could bring that 2 out of my integral sign without any problem. Okay, Terrell, Andy did so well. You think you can give me a function? Sine t, excellent choice, Terrell. Shit. You guys, anyway. Bunch of straight men. That is such a boring choice, Terrell. I don't believe it. I will pick my own choice. I'm going to pick e to the omega jt. There, that'll teach you. Is that a better choice? Where j is the imaginary operator. Okay, so that's a better choice.
It's omega.
Frequency, radians per second.
Okay.
It's angular velocity. I don't care what it is. It's omega. Doesn't matter. Does it matter what it is?
No, it doesn't.
No, of course it doesn't.
Sorry.
Yeah, you sure are. Okay, so f of s is integral 0 to infinity of e to the omega jt e to the minus st dt. All right, so that's going to be 0 to infinity e to the omega j minus s t dt. And that's going to be limit b goes to infinity of e to the omega j minus s t divided by omega j minus s evaluated at 0 and b. All those things are really obvious, right? I mean, so far, nothing's up my sleeve even though I have a long sleeve shirt on. All right, so I've got limit b goes to infinity. I'm going to put a b in for t. So I have e to the omega j minus s b over omega j minus s minus 1 over j omega j minus s. Oh, I hope that's right. All right, now, as b goes to infinity, as long as minus s is smaller than j omega, this becomes 0, and this whole thing goes to 0 as we go to infinity. So the Laplace transform is going to be minus 1 over omega j minus s. Now, what does your 9th grade algebra teacher tell you about radicals in the denominator?
I don't remember.
Yeah. So if you had 1 over the square root of 2i, or not even 2i, just 1 over the square root of 2, would that be an allowable answer, or must you rationalize the denominator and say this is the square root of 2 over 2? Your 9th grade algebra teacher would have told you to rationalize the denominator. All right, so I got to rationalize the denominator just because my 9th grade algebra teacher told me to. So this is going to be 1 over s minus omega j, because I'm bringing that negative sign down here and turning things around. So I'm going to multiply by s plus omega j divided by s minus omega j. And when I do that, I'm going to have s plus omega j divided by s squared plus minus omega squared. Minus omega squared? Yeah, minus omega squared, right. All right, so I've rationalized the denominator. Now, so f of s is equal to s divided by s squared minus omega squared plus j omega over s squared minus omega squared. Now, the original function we had, we all remember, was e to the omega jt, right? Remember that? And you remember from this series of approximations we did that e to the omega jt is cosine omega t plus j sine omega t. You remember that?
Kind of.
Yeah, kind of. Okay, now, so if I take the Laplace transform of this guy, which is what I did, I have an imaginary part and I have a real part. Are they linearly independent of each other? Yes, they most certainly are. So the Laplace transform of cosine omega t is s over s squared plus minus omega squared, and the Laplace transform of the sine of omega t is omega over omega squared minus s squared minus omega squared. Okay, so we're done doing that. We're now turning the page and looking at page 1047, and on that page we have 12 Laplace transforms. So all we're going to do is use them to solve. This is our Laplace transform table. We're going to use it to solve differential equations. We're going to put the differential equation into a form that's we can solve using algebra. We're going to solve it in algebra, and then we're going to do a reverse Laplace transform and bring it back. So that's the plan. Now, in the differential equation book, their table is 10 deep. Our table is 23 deep. I go and copy our table and give it to them. So they use the same Laplace transform table we do because it's so much easier to use this one than the stupid one in their book. There exists in the Handbook of Chemistry and Physics over 250 Laplace transforms. So there exists a whole ship out of. If you need more, you can. But from an electronic point of view, we're going to use the e to the at guy, and we're going to use the sine and cosine guy all the time. We're not going to use some of these other guys because they're not electronic in nature. Okay, so that's our plan. And on the top, equation 1, it's telling me that these guys are what is that called? They're additive, I guess. And it tells me what the derivative, if I have a first derivative, what the Laplace transform looks like, and if I have the second derivative, what the Laplace transform looks like. And we have to know the conditions at 0, otherwise it doesn't work at all. All right, so those are all things that are running through our mind right now. And we're going to do number 9 first. Okay, so number 9, we have f of t is equal to sine 2t minus 2t cosine t. That's what we have. And we want to take the Laplace transform of those guys. Alright, so we turn back to our Laplace transform table. We notice that the sine function is number 8 on our Laplace transform table. And we notice that t cosine t, where's t cosine t? It's number 19 on the Laplace transform table. And then we write down that f of s is 2 over s squared minus 4 minus 2 times s squared minus 1 divided by s squared plus 1 squared. And we're all done. That's all there is. There ain't no more. We'll just go and write down the answer. I know it's pathetic. Totally pathetic that we had to go all the way through calculus, integration, differentiation, just to get to Laplace transforms, where all we do is have one lousy line. I know, it is. All right. So math is turned around, complete circle, we're now back to 6th grade math.
Sweet.
Is it harder than that? Yeah, it might be harder than that, but not today. All right, so next problem. Next problem is number 10.
Wait a minute, 18.
Oh, 18?
It was
Wrong?
56 and then 18.
Oh, well.
No, we just did 9, right?
Yeah, but we're supposed to be on 3-5.
Oh, we should have done 6.
Yeah.
Oh, so you should have told me I had to do 6.
I didn't realize it.
I tried.
All right, number 6. You tried, yeah. Yeah.
Why try?
Number 6. I have f of t is 1 minus cosine 17. And I want to take the Laplace transform of this thing. I find that this guy here in my Laplace transform table is number 4. And I find the cosine function to be number 10. And I write down the final answer, f of s is equal to 1 over s minus s over s squared minus 49. Check. It's plus 49. No problem. That means I fucked up that other thing, but that's okay. I know. All right, we're going to move back. Back. Not that far back. All right, this guy here. Right. When I square this guy, minus. That's a minus W. I did something wrong. How is that possible? Anyway, we're not going to worry about it. I get it right most of the time. That's all it matters. Okay. So I did number. Oh, undo. Okay. Oh, that was good. All right. So now we're going to do, after number 6 comes number 18. So I hope they get harder than this. 18. F of t is t sine 4t plus t cosine 14. And I want the Laplace transform. And I see that this guy is number 18, do you say? 18. And this guy's number 19. And I write down f of s is, looking at 18, 2s, no, 4s divided by,
Wouldn't it be 2 times 4?
no, because k is 2, well, I don't know.
2ks?
Yeah, so it's 8s,
I think so.
2k, k is 4, right. K is 4, k is 4, right. So that'd be 8s. 8s divided by s squared plus 16, the quantity squared. Hope I'm looking at the right one. And then 19 is going to be s squared minus 16 divided by s squared plus 16, quantity squared. And so that was 18. And then 23 is next. Number 23. Alright, so I got y double prime minus 3y prime plus y is equal to 0. And y at 0 is 1. And y prime at 0 is 0. Okay. Do I get a 4-0 for writing the problem down right? They don't have an equal to 0 there, but it really is. Now, no, what do they want? They just want me to do the Laplace transform. They don't even want me to solve the problem. So if it's equal to 0, I can solve the problem. If it's not equal to 0, there's no problem to be solved. But I can write down the Laplace transform of this guy here. All right, so that's what I'm going to do. Going back to my Laplace transform table, I find that's number 3. That's number 2. And I don't even have one for that. Well, this is number 1. All right, so I've got to have s squared y of s minus s y at 0 minus y prime at 0 minus 3 times s y of s minus y at 0 plus y of s. So that'd be the Laplace transform. I would then put in my initial conditions. This guy's 0. The other two guys are 1. So I'd have s squared minus 3s plus 1 y of s minus s. That's minus 1, but it's times minus 3, so plus 3. So that would be my final answer. Now, if I had this guy equal to 0, then I could solve for y of s, but they didn't ask me to do that, so I'm not going to be an overachiever. Back to 34? 34. Okay, so I've got number 34. F of s is 2 over s plus 2. All right, so now that this begs the issue. First of all, do I have that in my book? And
13 is close.
yeah, I do. 13. So this is number 13. So if I take the inverse Laplace transform of that, I would get f of t is equal to 1. 13 there, right? So then a has to be a minus 2. So minus e to the minus 2t. And that's all there is to that guy. Just go over this with your grandchildren tonight, there, Grandpa.
My grandchildren?
Yeah, I know you don't have any grandchildren. Well, you claim to not have any grandchildren.
My son is 8 years old. If he had children,
48.
I'd be on CNN.
You would, yeah, you would. That's absolutely true. I hope number 48 is harder. Now, that's not the way I would have solved this problem in the differential equation class. I would have done a partial fraction on this guy, but I don't have to because I already have the right answer. 48. So I've got f of s is 3s minus 4 divided by s plus 2 times s squared plus s plus 3. Okay, well, I look at that and I say, well, I don't think I'm going to have that on my Laplace transform table. Yeah, you bet. And I look and shit, I don't see it anymore. Okay, so what I'm going to do is I'm going to do a partial fraction. If you knew the answer was 1/2, what was the question? Well, it could be 3/4 minus 1/4, right? So I know the answer is that. And so the question is, if I have a over s plus 2 plus cs plus bs plus c over s squared plus s plus 3, then what's a, b, and c? Okay, so I would say, well, I'm gonna go and find a common denominator. A s squared plus as plus 3a plus bs squared plus 2bs plus cs plus 2c, and that's going to have to equal what's on the top here, 3s minus 4. 3s minus 4. All right, so then I say, well, the s squared term, that's an a plus a b, has to be 0 because there is no s squared term. The s term, a plus 2b plus c, has to equal 3 because that's my coefficient there. The unit term, 3a plus 2c, has to be minus 4. Okay, so now I have 3 equations, 3 unknowns, and I have my formula for 3 equations, 3 unknowns open. So I'm going to put a 1, 1, 1, 1, 0, 0 there, and then I'm going to put a 1, 2, 1, 3, 1, 2, 1, 3 there, and then I'm going to put a 3, 0, 2, minus 4, 3, 0, 2, minus 4 there, and I'm going to get that A is minus 2, A is minus 2, B is plus 2, and C is 1. And I'm going to look back in here, and 6 minus 2 is minus 5, and they all check. Okay, so that being the case, I have something that's in the form minus 2 over s plus 2, I think. Is that what it is? S plus 2, right? Plus 2s plus 1 over s squared plus s plus 3. All right, now, I haven't done anything but use algebra so far here, so that's good. I can do the Laplace transform of that guy. I see him. He is number 7, so I can do him. That guy there, the other guy I don't see right offhand. Can I factor him? No, he doesn't factor. So if he doesn't factor, so I'm going to call this minus 2 times 1 over s plus 2 plus, I'm going to complete the square on him. S squared plus. I take the 1, divide it by 2, I get a 1/2, I square the 1/2, and I get a quarter. I get a quarter s plus half squared, I get a quarter, but I get that guy. Okay, and then I got to take a quarter away from, I have to take a quarter away from this guy because I have an extra quarter over here, so that makes this 2 3/4. Oh, did I do that right? S plus a half squared. So I'm going to have s squared, I'm going to have 2 times a half squared, which is s, plus a quarter, plus 2 3/4, which is 3. Okay, so I did that right. So now, this guy is number 7, and the other guy looks like 9 and 11. Looks like number 9 and number 11 combined. Okay, so I'm going to rewrite this guy as minus 2, 1 over s plus 2 plus. Okay, now, number 11 needs an s minus a. Okay, and a is a half right now. So I need an s plus a on top. Okay, so I'm going to multiply this by 2 times s plus a half over s plus a half squared plus 11/4. 11/4. Alright. And now I look at 11 again, and I'm in the right form for number 11. Alright. Number 11. Number 7. I'm going to take the Laplace transform, inverse Laplace transform of everything, and say f of t is equal to minus t e to the minus 2t plus 2 times, looking at number 11, e to the minus a half t cosine square root of 11 over 2t. Ta-da! And are we doing an odd problem?
No.
Good. All right, so we'll check it. Okay, so, and it's not f, it's y, right? Y at t. So y at 0 is supposed to be what? Y at 0, where's my initial condition? Oh, I had to have it. No, I don't need initial conditions. I'm just finding the reverse Laplace transform. Alright, so I'm there. I'm done. It must be true. What can I do to make you believe me?
Do it in Maple.
Okay, if I do it in Maple and get the right answer, we can go home. Is that what you're telling me? Otherwise, I have to do it until I get it right. Okay. Okay, so we're going to do it in Maple and see if I come anywhere near to the right answer whatsoever. No, good laughing over there. So Maple help, we want inverse. Oh, way to go. Inverse Laplace transform. That's spelled too many things wrong, probably. Who knows? And why am I not searching? Search. Inverse. Inverse. Is inverse spelled with a C? Oh, there. Inverse Laplace transform. All right. All right. So there. That's all we need. Just that right there. Control copy. Control V. All right. So what do I have for the problem? 3s minus 4. Parentheses 3s minus 4 close parentheses divide by s. Better put another set of parentheses in. Parentheses s plus 2 times s squared plus s plus 3 close parentheses, close parentheses. Do I have enough parentheses now? Okay, I might. Boom. Alright. S, 3s minus 4, s squared s plus 2s squared plus... Now, why isn't it giving me an answer?
There again.
Expand.
No, it should just give me an answer. Do I have too many spaces here? Is that what it's complaining about? Comma S, comma T. Stupid Laplace transform people anyway. B. Wow. What happened to my karma today anyway? See, this clearly says that if I do that, I get that, right? Copy, paste. Wow. What I do, did I let my license expire or something? So there's some Bessel function thing. Which god did I piss off this time anyway? Inverse Laplace one divided by s plus 1 comma s comma t close parentheses, enter. Okay. Did I not do this first?
You got an answer up there.
Oh, I got it. There we go. I must not have did a return on the with Laplace transform guy. Okay, did I have minus 2 e to the minus 2t plus 2 e to the minus a half t cosine 1/2 square root of 2 over t? Is that what I had?
Cosine square root of 11 over 2.
Yeah, square root of 11 over 2. Yeah, that's exactly what I had, right?
Yep. Exactly.
Exactly? Exactly, exactly?
Yep.
So if I go and I copy this and I put it over here, I'm going to get exactly, it's going to show me the exact same thing.
Not exactly. Written a little bit different.
Stupid thing, anyway. Alright, so minus 2 exponential minus 2t, 2 exponential. How come this isn't 1/2 t?
It was half t.
It was half t before they messed it up? Yeah, it is a half t.
I don't know why they got minus 12.
Okay, I know what we're doing. Here we go. We're going to do it one more time. I'm gonna skip you. Oh, come on down. Oh, what did I do? Have my hand someplace. Doesn't look like it's copying it. Is it copying it? Yes, it is. But it didn't get the 1/2. Oh, okay. We'll try it again. Okay, I know. There, is that big enough for you, stupid
I
computer?
can see it now.
Can see it now? Can you see me now? Okay, very good. I got some extra stuff there, but copy, cut, cut, and we're up here. Down there, edit, paste, get rid of this guy, delete, there, perfect,
Perfect.
or what?
Excellent.
The only thing I have different is I have square root of 2 over 2 instead of 1/2 the square root of 11. I have square root of 11 over 2. Excellent. Control, Alt,